We have transitioned from the client-server model to complex megascale applications within a short period of time. Batch computing requires high performance for large amounts of capacity on demand. IoT application changes paradigm and typically combines the traits of cloud-native applications along with big data apps. There's a lot of pressure on the data center now. Monthly compute availability SLAs are of 99.95%, are a standard offering. Some providers now have to offer multi-fault domain SLAs, where an SLA violation requires both fault domains or availability zones to fail. Machine learning, automatic driving, heavy analytics form a new era of application that needs to be supported by hyperscale infrastructures. Hyperscale's ability to scale, for example, compute, memory, network, and storage resources appropriately to demand to facilitate distributed computed environments. They employ a disaggregated architectural approach scaling to well over 50,000 servers, often seen in cloud computing and big data environments. Hyperscale architecture is a secret source for Facebook and Google. It allowed them to efficiently respond to massively complex workloads while also lowering their costs. If you have around 100 servers, virtualization may be sufficient. However, shifting from physical boxes to virtualization in cloud computing can only help you to a certain degree. When you reach the 1,000 server mark, new efficiencies in hardware must be supported. The 10,000 server mark usually means suppliers operate their own data center environments. Workloads need to be optimized and configured to run only on certain hardware platforms. The 50,000 server mark is where the big players like Facebook and Google come to play and design their own servers and even optimize their silicon. They may specifically design a type of server just for that use case, for example, cold storage. Within this server region count, there will be a lot of compute and workload optimization. The workload needs to be optimized to work more efficiently for different types of computers. The level of customization increases as the scale increases, and in the past this was generally only available for the big players. However, the barrier for hyperscale environments has now been lowered with the introduction of projects such as the Open Compute project. The Open Compute project helps to introduce the normal organization to enter the high level of megascale environment that previously was only available to the big players. Jason Maxman from Intel presented at the Open Compute Summit 2018 and mentioned the introduction of a couple of new projects to aid the OCP deployment to the next level of hyperscale adoption. For example, to increase compute capability, Intel have updated the Tioga Pass and Olympus designs to support the latest Xeon scalable processor coupled with the latest SSDs. Also, to make SSDs more flexible and scalable, Project Denali will use a combination of Intel Optane technology and Intel 3D NAND to address some of the storage challenges that we are seeing in hyperscale data centers. Also, Ericsson have introduced the HDS 8000, which offers hyperscale computing in a box. All compute, storage and network resources are physically assembled into this hyperscale pod, communicating through an optical backplane. All the resources from the pod are then redistributed in a virtualized performance optimized environment called a virtualized pod, a vPod. The resources contained within a vPod can be physically dispersed, but they function as a single logical system.